Welcome back, everybody, to another Summer Smasher Student Showcase presentation. Right now, we have Team ViyaMD, a group of students who've been helping one of our fall teams this summer, and we're going to hear what they were up to for the past 8 weeks during Summer Smasher 2024. Take it away, Team ViyaMD.
Hello guys, my name is Sanskruti and we are Team ViyaMD, a unified platform for optimizing clinical operations and care. Today's healthcare providers face critical challenge. Electronics health records are meant to streamline care, are instead taking nearly half of physicians' time with paperwork and manual data entry, which leaves around 27% of actual time for the patient interaction. ViyaMD is changing this paradigm. The AI platform acts as a digital clinical companion, which emulates like a top medical expert, which provides the kind of knowledge and expertise that you would expect from the specialists in each field. The precision-tuned LLMs are developed specifically for healthcare, and it ensures unparalleled accuracy and reliability. The comprehensive solutions tackles 5 key areas, including contextual insights, patient engagement and care, provider clinical workflows, clinical operation, and health data analytics. ViyaMD is not just improving healthcare technology, but it's also transforming the whole healthcare experience for both providers and the patients. Now, I would like Kusum to carry on the presentation.
Thank you, Sanskriti. So I was tasked with building with the retrieval systems, and it's, I think, first very important for us to understand why retrieval systems are important for us in this situation. So usually the LLMs suffer with problems like not having up-to-date information during its training, and they sometimes suffer from not even understanding the context of the question. So for these situations, retrieval systems is the best solution. In this retrieval systems, let me just explain first how a retrieval system works. As we can see in the image, once a question is being asked, the retrieval system checks a knowledge base, retrieves the relevant knowledge, and then that provides it as a context to the LLM. And then this context is then used to create a generation. So this is very important for us as this gives us better context, and in the knowledge base, we can make sure that there's only data that is related to the medical field so that it has a better understanding of the domain. And something that recently we have witnessed is that medical field is a evolving field, and there's a lot of decisions that get affected because of the knowledge that gets getting improved. So constant learning is another factor that retrieval systems provide us as an advantage. And the particular reasons we can see it's important in patient safety in medical industries that it provides patient safety and improved patient outcomes. Next, I would like to pass it on to Anirudh.
Thank you, Kusum. I also worked on the retrieval system. However, it was part of the ingestion. So as Kusum mentioned, in a retrieval augmented generation or RAG system, we have data that's taken right from the vector database and fed to the user output, which can be read by the user. Now, to process data from any given format to the database, we need an ingester, which is where the original ingestion system came in, which had several problems such as incomplete data or an inconsistent information flow. My task was to update this information flow and make it more streamlined and try and account for the inconsistent data. I worked on many different ingestion methods, serving different papers and different open source, as well as different APIs. Eventually, I settled on an ingestion method which had been tried and true and had much potential to be improved for the time that I was working during the Summer Smasher program, as well as in the future. So while creating the new and improved ingestion pipeline, I modified the typing system and made it account for different kinds of data, such as paragraphs, images, and tables, the kind of data you would find in any given type of information format, and in this case, a PDF. And I also revised this ingester so that we can include its capabilities for extracting tables and images. Having built all this, the ingester can now effectively extract tables and images, and can also help the developers evaluate any new approaches being tested, and it can be helpful to ingest data properly and can help the retrieval system in general. Thank you. I will now pass it on to Sanskriti to explain the evaluation pipeline.
Thank you, Anirudh. I was a part of the RAG evaluation pipeline team, and here my key task was to evaluate the accuracy of the extracted PDF content, and I compared the extracted content with the prediction files against the ground truth files. So I will explain the process flow in brief. So first, it used to read the directories for the ground truth and prediction files. Then it reads and compares the contents and computes various metrics like percentage correctness, headings for each levels. It computed metrics known as precision, recall, and F1 score, and also I computed table accuracy. So finally, it in the reporting phase, the pipeline aggregated all the results and it logged the key metrics, and it provided a comprehensive overview of the evaluation. It highlighted the key areas and those needing the improvement. The evaluation pipeline can process large number of documents quickly. So the eval pipeline is not just about measuring the performance, it's about the improvement. By identifying specific areas for enhancement, we can continuously refine our the PDF extraction methods. In conclusion, PDF evaluation pipeline for RAG system, it represents a significant step towards content extraction technology, and the actionable insights that we get from the metrics, it can indeed make the entire RAG system more robust. Thank you so much. Now I'm going to pass it to my teammate Ravneet, who is also one of my friends at USC.
Thank you so much, Sanskriti. So hi everyone, my name is Ravneet Kaur. I worked on custom LLM fine-tuning pipeline. So basically a custom LLM fine-tuning pipeline is the process of taking a pre-trained model and specializing it for a specific domain. In our case, it was the medical domain. So a pre-trained LLM, it's trained on massive amount of general text data, but it does not performs that well when we want it for a specific domain. So fine tuning is the process where we take the pre-trained LLM and give it a specific focus. We do this by feeding it a new smaller data set of text relevant to our desired task, which was the medical field. And for our task, we have used a data set which consisted of medical question and answer pairs sourced from a healthcare magic, an online platform where users post medical questions and they receive answer from the doctors. So for the implementation part, first I researched on various fine-tuning techniques, which included full fine-tuning. But for full fine-tuning, we needed a large amount of computation power. So we decided to go ahead with something else. So when we came to parameter efficient fine tuning, there were a lot of methods in that as well, such as partial, additive adapters, and reparameterization. So we finally decided to proceed ahead with LoRa, which is low rank adaptation, because it introduces a small number of additional parameters instead of updating the entire sets of model weights, which basically reduces the computational burden. So initially we decided to train it on a smaller model like BERT for question and answering, but when we use BERT, we need an extra column, which is context. But the question and answer pairs which we had, there was no extra column for context. So this BERT model could not be applied to that. So we identified this problem early, and then we decided to move ahead with the Llama 3 8 billion parameter instruct model. So we finally fine-tuned the Llama 3 8 billion instruct model using LoRa with PyTorch Lightning. This involved constructing a comprehensive pipeline for running inferences, which could lead to notable improvements in the model performance and reliability. Thank you. Now I will pass on this presentation to Niranjana and Rutuja, who will continue it. Thank you.
Hi. So, hi, I'm Urvi.
Yeah. Sorry.
Yeah. Hi, I'm Urvi. I worked as a product intern with ViyaMD this summer. And I worked on the automated medical coding part of the product. So what is medical coding? Medical coding is the process of essentially translating healthcare diagnoses, procedures, and equipment into alphanumeric codes. So basically, medical coders review these documentations that are generated by the doctors in the physician's office, and they assign appropriate codes for it. Why are these codes relevant? These codes are crucial for billing, reimbursement, and healthcare data analysis. So I worked on two aspects. The first one would be product and market research. So I conducted extensive research on all the universe of codes and categories that are out there, which are required for both inpatient and outpatient medical coding. For instance, ICD-10 codes are used for diagnosis and inpatient procedure codes, whereas CPT or HCPCS 1 level codes are used for outpatient services and procedure codes. HCPCS level 2 are used for equipment, drugs, and supply codes, and so on and so forth. Other coding examples include E&M and hierarchical condition coding. I also obtained reliable and official sources for these codes and descriptions, considering the best methods for integrating them into a product. I also worked on developing low fidelity wireframes and envisioning user flow of the medical coding feature within the product. This would enhance the outpatient experience by streamlining processes, increasing efficiency, and reducing the time required for both medical practitioners and coders on the time spent on the coding part, and just focus on the patient and reducing the turnaround time for billing. I'll now pass on to Niranjana and Rutuja, who worked on the tech aspect.
Hi, I'm Niranjana, and me and Rutuja worked on automating this process of medical coding using LLMs. Medical coding poses a lot of challenges, including like manually doing it would be labor intensive. And there are a lot of labels. For example, ICD-9 is one of the coding style, which has over like 140,000 labels associated with it. One of the challenges is also that the inputs, which are the physician's notes, are often long sequences and they exceed the model's token size. We also have this problem of imbalanced data distribution, wherein like something like common cold or fever would have a label that occurs more frequently compared to something like Down syndrome, which is like rarer. So to tackle all these challenges and to create a specialized machine learning model, we would first need a reliable data set. We worked on researching the different data sets available, and there are like Mimic 3 and Mimic 4 data sets, which are open source, and they contain like several information, including patient demographics, vital signs, procedures, discharge summaries, along with the associated codes. So I worked on enhancing this data set and creating a specialized data pipeline so that we would provide inputs to the machine learning models that we create. First of all, I worked on integrating the different subsets involved in the data set and filtering them based on the codes available and applying different pre-processing techniques to them. So we would have like specialized fields associated, and those would be given as model inputs to these models. And I worked on this data pipeline. We also worked on different models and research, which Rutuja would explain in detail about. I pass on the mic to Rutuja.
Thank you, Niranjana. Hi, everyone. I'm Rutuja. I'm going to talk about the modeling aspect of this project. So we initially started off by looking at the state-of-the-art methods that are present out there for medical coding. And our aim was to either try to improve or fine-tune them. And one such approach that we stumbled upon was the pre-trained language model, the PLM-ICD paper. And we focused on 3 key tasks. First is understanding the approach in the PLM-ICD paper. We began by thoroughly studying the methodology that had been presented in PLM-ICD paper, which was basically crucial for our subsequent implementation. The second part was implementing the PLM-ICD code, which is basically we translated the theoretical concepts from the paper into practical code, ensuring that there was like accurate replication of the proposed approach. The third part is refactoring the code with PyTorch Lightning, which is basically refactoring the code which is present in the PLM-ICD paper into PyTorch Lightning framework. And this transition was basically aimed at enhancing the modularity and the flexibility of the code, and hence allowing for easier experimentation with different backbone structures and like a more streamlined training process. Next slide, please. Yeah, so I'm just going to quickly talk about the approach that was proposed by the PLM-ICD paper. So Niranjana had previously talked about what are the 3 problems that are encountered when we try to use the pre-trained language models for ICD coding. And I'm basically going to quickly walk you through the approach that has been used by PLM-ICD to overcome these problems. So for the long input sequence problem, they have proposed the approach of segment pooling, which basically involves splitting the lengthy document into smaller segments and then applying a pooling operation to aggregate information from these segments. Now, this technique allows the model to manage and process long text more effectively by capturing only the essential information from different parts of the document, and hence improving the performance of pre-trained language models in ICD coding tasks. The second part they have proposed is label attention. This is a solution for the large label set problem that Niranjana previously talked about. So the label aware attention mechanism works by integrating label specific information into the attention mechanism of the model. Each label or each ICD code is basically represented by an embedding that captures its semantic meaning, and the models and like during the model's forward pass, the attention mechanism uses these label embeddings in order to weigh the importance of different segments of the input text. Specifically, it calculates like the attention score that highlights the part of the text which is more relevant to each label, and the model then sort of aggregates these weighted sentiments to produce a representation which is more informed by a specific model. And the third part is domain-specific pre-training, which is a solution to the domain mismatch problem. Now, like ICD coding is basically a domain-specific task where input text consists of clinical notes which are written by clinicians, right? And the notes might contain several biomedical terms that are very specific to the medical domain. And understanding these terms is essential in order to assign ICD codes correctly. And the problem with general pre-trained language models is they are pre-trained on a large amount of text, and the pre-training corpora usually does not contain biomedical text. And it certainly doesn't contain clinical records. So domain-specific pre-training basically aims at pre-training our PLMs on specific data sets like Mimic 3, Mimic 4, which consists of clinical notes. That's it from my side. I would pass on the mic to Akanksha.
Hey everyone, thank you, Rutuja. So I'm going to be talking about the agent generator and compiler project that I worked on. So the main problem that I was trying to solve is that complex problems such as like post-surgery follow-ups or vacation planning require generative AI agents to use deep reasoning. So basically the simple single prompting approach that you use in GPT isn't sufficient to kind of solve these problems. In order to solve this, I used a series of approaches which kind of built on top of each other. So the first approach was a simple super prompt generator, which basically just created a better prompt simply by having it define a role, task, steps, and example outputs. The second approach after that, which built on top of it, was a questioning prompt generator. So instead of simply having it generate a new prompt, it also asked some questions about the user about what it can expect as input, and that helped improve the final prompt. The third approach was then a single prompt approach, which defined a context for the steps before the steps occurred. So basically, the context helps the final output to kind of know what the user is going to be providing, and it helps a lot. So like each step can also have its own role, and the intermediate outputs generated from each of the steps are also stored, and outputted, which helps in generating that final prompt. And the final approach was a knowledge base in which each of the steps had its own role and context. So each of the steps kind of acted as their own agent. And this kind of was like the ultimate solution to this problem. In the future, I'd like to refine this kind of multiple agent approach and kind of dig into it more by improving role specialization, and also have like cross-validation and feedback loops involved. Thank you, and I'll pass it off to Akanksha now.
At ViyaMD, we are constantly focused on optimizing healthcare processes and hence expanding our current solution suite. I'm Akanksha. I helped the team this summer in identifying, scoping out, and mapping a new product in the utilization review space. To introduce the utilization review space, it is essentially the steps and the guidelines and the framework that the hospitals and the healthcare
ecosystem has come up with to ensure that the quality of care and medical necessity for the steps that are taken by our doctors and healthcare systems. There are multiple guidelines that sort of help professionals to deliver the care, quality care that is required from starting from professional medical bodies to industry standards and their own doctor training and clinical reasoning. There are various points where utilization review or case management interacts with patient journey as they go through their entire process. The reason why we looked into this space is because we are facing shortage of quality medical staff and the existing workforce, and it ties very strongly to our key objectives of improving patient safety and reducing the physician burnout. Medical insurance and payer insurance policies are very complicated and messy. It's 2024. Healthcare insurance should not be that complicated. In order to build this, we understood the current users, the current market space, and we do have a lot of players in this space. This was followed by standard product development steps, for example, mapping our existing user journeys, identifying the pain points, and designing the new workflows which integrate seamlessly in process. We also clearly identified value proposition of our new product, the functions and the features that should be built first. We developed some mock UX so that our engineering team has some idea as to how we are looking at building this product, whether it's different users, workflow for that, as well as decision support through aggregated analytics dashboard. The next step is validating some of these alpha and beta features that are in pipeline, reaching out to our potential customers, networks, and basically robust testing with clients. You can also see on the slide a mock-up of how this might look like for one of our potential users. Next, I'll pass it on to Kusum to share our overall experience.
Yes, so thank you, Akanksha. I think I'll be representing all of us to tell that firstly, we are really thankful to Hari, Josh, and ViyaMD in total for giving us this experience. And as we can see, the projects were pretty intense. They were very involved in the medical field, and it is a field that has to be accurate and that needs a lot of automation to make sure there's less and less of human error. And for all of us, it was a journey where we learned a lot of new things, and we learned how to be better at coding. We learned how to be better at approaching problem, and through these 8 weeks, I think everyone has gained so much from this that everyone has been had the best experience over here. And moving to the next slide. Yeah, so these are our contacts, and we will definitely be open to exploring new projects and exploring new opportunities. So please feel free to contact us. Thank you so much.
Excellent job, Team Via. Let's see, do we have the founders on the chat right now to say, I see Josh.
We do indeed. Hi, everyone. I know I speak for Hari when I say that we have been absolutely blown away by the skill, talent, and dedication that everyone brought to this, the various projects this summer. It's been such a privilege to work with each of you, and we are genuinely so grateful for all of the extraordinary contributions. So thank you all again.
Yeah, thanks also from just VSG. Johanna, myself, David Gerber, we work really hard to make sure that you guys have the best experience possible. Our hope and goal is that when you guys leave Summer Smasher, you guys feel more empowered to become entrepreneurs yourself, and maybe you can explore some opportunities. I do think the future is technical, and you guys are perfectly positioned at this point as technical experts with some business acumen now and a little bit of an understanding of how it happens early on to leave the Summer Smasher and maybe go start something yourself. So please I hope that you feel empowered the same way we want to empower you, and just honestly, thank you so much for all of your hard work.
Thank you, Arcelia, for the program and everything.
Yep, thank you, Arcelia.